from Uzao AI. We're an AI startup based in Kiambu. So this is our submission for the Microsoft Fabric Hackathon. So everything that we've done is available in the README, the repo. Also have a couple of other files just to set up. So our solution, our proposal is a sales and demand forecasting solution for local retailers. We implement a medallion architecture that ingests, cleans, transforms, and model historicals, sales, and relative inventory data to generate accurate future demand. So this has a lot of obviously applications. But let's look at the high level architecture from our side. So we have data ingestion. So these are the keys. So we have bronze, silver, and gold at the different zones. And we'll get into that in a bit. So we ingest data basically using a data flows into, and then we have three lake houses for storing the data. We access all the data using one lake. And then we apply transformations from step to step. And then we have visualizations and machine learning and also generative AI at the end of the tail of it. So these are some of the outputs that we got. That's all other the notebooks that we used. All of them are here, are linked in the README, and they are all in the repository. So we can look at how that looks like. Also, sorry, we also added pipelines for deployment using Azure DevOps. So let's look at how that looks like on Fabric. So this is how the workspace looks like. So we have different layers, and then we sort of move the data. We ingest the data from low volume data ingestion into different lakehouses, apply transformations repetitively until we sort of get what we're looking for. So we do that with using a single notebook. Quickly show where it is. So this is the notebook. Just a minute. Yeah, it's taking a bit of time to load. Yeah, so at this point, we already ingested the data into the lakehouse. So this is what the notebooks looks like. Still loading. So I can quickly go through it. So we connect to the lakehouse, and then we sort of display the data that we have. Just minimize this. Yeah, so you can sort of see the outputs here. Still loading. So this is the data. It's a lot of data, a lot of rows, but we're just displaying the first 100 rows. After that, we work on cleaning. A lot of this others work on cleaning, standardizing, and removing, null values, repeated columns, that kind of thing. And then we insert the data into the next lakehouse. Repeat, rinse, repeat, until we get the actual shape that we're looking for. We used a lot of Fabric's offerings by Arrow and Spark. Using Fabric were really helpful. So a lot of it is just pivoting the data in, pivoting it out. So removing sample data and necessary columns that we don't need. You can sort of see that here. And then so you can see this is like that cleaned data. Then we move to unpivot the data so that we can sort of shape it in a way that we want to manipulate. And you can see all this does that. So we have reverse mapping of codes to some of the branches, so some of the stores, and so a lot of that functionality is just executed here. It's quite a long sum, but we load data. A lot of this is you can see loading data from this lakehouse into that, pulling it out, working on it, and then reloading it according to the stage that we're in. So it's sort of the results. So you can see the store numbers and then the top 5 stores by row count. So these are the stores that had the most data. And then we can sort of start working on it, our forecasting model. So we use different models. The first one we used was profit. This helps in seasonality, so you can sort of understand what happens at what time of the year based off this data. So we ran a lot of that using profit. So this cell works on that. So we load data from the gold lake house, and then we work on it using the profit model. So this is basically it. So these are some of the results of forecasting. You can sort of go through it. Did overfit some models, underfit some, but there's always a lot of room for improvement. Then so this is demand forecasting across 12 periods of forecast data. We also added another model just to sort of compare what we got with the profit using Fabric's AutoML. So just wait for the notebook to load. Yeah, so we use scikit-learn. A lot of this model was just provided by Fabric. We just tweaked it to make sure that it matches the data and it fits the shape that we wanted. So it uses fast and lightweight automated machine learning. It's an open source framework. So we use scikit-learn, and then we optimize the notebook and ensure that we configure login. So we load the data, and then we use AutoML to find the best model, and then we start tracking the results. So here's what that looks like. Yeah, so we load and process the whole data. So you can see some of the columns and some of the test columns and the train columns that we assigned. Unfortunately, this doesn't take in a lot of data, so we had to sample with a couple of rows, sort of trial and error to see what gives us the best results. So everything is here, the settings, all of it, all the code is here and also available on GitHub. So this is what that looks like. Excuse me. So we basically forecasted price against month. So we wanted to look at the time series data of price against month. So you can sort of see that this is what happens. So that this is training data and the testing data. So from here, the model is ready with the trained data. You can see all the experiments that were run. You can see all of them succeeded successfully. Now we saved the model and then generate the prediction. So a lot of the code, all of it is here. Then you can also see the results here. And then we just save them to a table here. And then we joined the table and then started coding at least the first 20 predictions ordered by month. So you can see them. And then we just did a final join so that they can be compared against the existing values predicted. You can see actually a prediction error and an absolute percentage error. Of course, the explanations. And then we also have a dashboard for visualization. So basically, this just visualizes all the work that we've done, including prediction models, which is what we have here. On the blue lines is the actual data. And then from the gray, this is the predicted or the modeled predicted data. So you can see we have a brand name, we have a category, and then we have store name. So if we choose a category here, like say masalas, against this specific store, you can sort of see our cutoff for data was 2024, but you can sort of see how that can pan out. So this is the upper bound, the lower bound, and then the line of best fit. So you can sort of see the expected sales sometime in 2026, 2028. If we change that to say seasoning across the same store, you can sort of see the prediction of the predicted model. So this is a combination of both the models, both Profit and AutoML, to sort of get these visualizations. You can change the stores, sort of see how that looks like. You can see the brand is here, the categories are here, so you can sort of change that up and see how that flows with the prediction models. And then this is the overall dashboards with all the data and the store name location. You can sort of sift through that. A link for this is also available in the repository. And then finally, we added a bit of generative AI to the lakehouse. We used Azure OpenAI. The notebook is also here. So you can see we just set up the libraries. So we set up the libraries, then we set up the configuration, and then we load the data into the notebook. We used data frames from PySpark, and then so this is sort of like how the data looks like. And then not to date this, we provided some vectorization or ingestion for the large language model. We're using GPT-4o from Azure OpenAI. So this is the query and the prompt. So defined an argument, defined the prompt, and then we sent the data and a couple of checks to make sure everything is okay. Then here you can sort of tweak the questions and then ask. So this is the answer to this question. Identify any potential optimization points according to the cell strings. So you can see this is the response based on the provided data. There's some optimization points. There are low performing stores, store coded. So some sell 2 units, 9 units. So these stores might require better product visibility, shelf placement, market analysis. High performing stores, inventory distribution, promotional strategies, product performance, pricing overviews, and also a couple of steps. The prompt can be tweaked, obviously, to be more detailed and provide more information, more guidance. But this is the gist of it. So we combined machine learning, combined a lot of data analysis, and then we fed that all to the model. It's easy to connect from the lake house here, as you can see. Yeah, thank you.